I'm sure many of you will remember in the not-so-distant past, the IT marketplace was well segmented and well understood. Today, however, there is cloud, and practically every piece of hardware and software has now been labeled as cloud or something as a service. This, quite understandably, will have left many of you on the call today disillusioned and likely dismissing cloud as just another buzzword. I hope during this webcast to convince you that the cloud is something specific, and that even if you don't believe it is for you, it is worth your organization at least considering its strategic response to what I believe is a disruptive paradigm shift. I will first look to define cloud in terms of its most commonly used attributes and terms. This will include the 5 key characteristics that make a cloud, and what distinguish it from just a bunch of virtualized servers hosted in an off-premise data center. I will then go on to describe some of the main driving forces I believe are behind the transition to cloud computing, and I'll focus on one of them, commoditization, by describing some of its most interesting implications and proposing that the transition to cloud is inevitable for all of you in some shape or form, and perhaps sooner than you'd think. I will finish by briefly describing an approach to creating and deploying your cloud adoption strategy so that you can begin to consider the likely impact it will have on your business. So let's begin by looking at a definition for cloud computing. If we were to survey everyone on this call, it is likely we would discover as many definitions for cloud as there are participants. If you search the internet, you will find many more. The good news is that the industry does now seem to be more broadly accepting a single definition. It was drafted by the National Institute of Science and Technology, or NIST for short, and they propose the definition to be: cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, networks, storage, servers, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. They are, in fact, describing a category of utility computing, and I hope to demonstrate later in this webcast how utility computing is merely a natural evolution of IT capability. Other recognized utility computing models, such as grid computing, already exist. To be able to qualify as cloud computing and distinguish itself from being just a bunch of virtualized servers, a service needs to demonstrate 5 key characteristics, each of which is important if the subscriber to the service is to realize their expected benefits. These are on-demand self-service. This is normally achieved through the kind of online portal or smart device application. As you might expect, to efficiently deliver on this characteristic, there is a need to introduce significant levels of orchestration and automation. Otherwise, a small army of people may be needed to sat waiting to immediately fulfill end-user service requests. This particular feature means your cloud infrastructure, if you plan to build one, will need a user experience and begin to feel as much like an application as infrastructure. The key question is, has your infrastructure organization the necessary skills and experience to manage this? It also requires broad network access. As the name suggests, a cloud needs to make its capability available over a network to all its potential subscribers and to the plethora of heterogeneous client platforms from Windows desktops to iPads that comes with them. It may not be appropriate, depending on the nature of your business, for this access to be provided over the internet. So WAN connectivity to your chosen provider's cloud or even to your own needs to be considered carefully and planned for. Resource pooling. To efficiently provide on-demand resources, these resources will need to be pooled and shared across multiple tenants with diverse workloads, as this facilitates a smoother, more predictable demand profile. This is a key benefit of the multi-tenant model and allows for public cloud service providers to manage their infrastructure to much higher levels of utilization than single organizations may be able to on their own. To balance these workloads, however, providers need the flexibility to move these workloads around to smooth peaks and troughs, so this requires location independence of service fulfillment. Rapid elasticity. It is the rapid elasticity of performance and load that allows for tighter linkage between variable or unpredictable business demand and its associated compute power requirement. Those of you who run such businesses could benefit greatly. A classic example of this is a retailer who operates a turkey ordering system during the peak Christmas period. This infrastructure includes nearly 60 servers. They sell a lot of turkeys. And for most of the year, it is sat idle. Measured service. Being a measured service enables subscribers to realize the benefits of pay-per-use and a closer linkage between business revenues and IT costs. If you are looking to build a cloud internally, it is fundamental that you have a handle on your IT costs and you're able to charge back or at least expose the IT costs relating to cloud consumption. Otherwise, you'll end up with cloud sprawl and a much larger investment than expected. For those of you who are future cloud service providers, the nature of the new commercial models underpinning the cloud will likely have a significant impact on your existing back-office systems, and our experience tells us it could well be a major pain point during service implementation.